Welcome to Math 119, Chapter 8.1, where we talk about our fundamental trig identities. So far we know a few of the reciprocal identities. So cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. We also know some quotient identities, so that being tangent is equal to sine over cosine, and cotangent is equal to cosine over sine. So now when we talk about Pythagorean identities, there are 3. So keep in mind on your unit circle, right, we have your hypotenuse here with a radius is equal to 1. So in our case, because this is your hypotenuse, this is equal to C. And again, if we are on your unit circle and on a coordinate plane, we have your x-axis, your y-axis, and if this is some sort of degree, some sort of theta, right? Well, opposite, that is just going to be your y value. So this is your y coordinate. So y coordinate being your sine value. And as far as your Pythagorean identity goes, this is also your a. And your adjacent would be your x coordinate, this being your cosine value, and cosine can be represented as b. So when we put it on a Pythagorean theorem, a squared plus b squared is equal to c squared, and adding the element of now talking about your trig functions, a squared we said was your y, so a squared is really sine squared, or sine of theta, I should say, plus cosine squared of theta, which is your b, is equal to c squared, which we said your radius, your hypotenuse, is equal to 1, or 1 squared. 1 squared is just 1. So this is your first Pythagorean identity here. This is the one that we use a lot in our class. And then when we come to find the other two, what we can do is simply either divide by a sine or a cosine. So let's take this identity here. Sine squared of theta plus cosine squared of theta is equal to 1. Now let's divide everything by your sine squared. So notice that on one side, right, we have sine squared over sine squared. This ends up becoming 1 plus cosine squared over sine squared. Well, that is just another way to say cotangent squared of theta. Now, the reason why this is cotangent squared of theta is that cotangent is just cosine over sine. And now that both of these are squared, that means that our trig function itself will also be squared. Then you have 1 over sine squared, which 1 over sine regularly is cosecant. So we now have a cosecant squared of theta. Now this is your second Pythagorean identity. Now let's do it again, but instead of dividing by sine squared, let's do it again and divide by cosine squared. So if we do it all over, this time with a cosine, so sine squared theta over cosine squared theta, that will become your tangent squared of theta plus 1, or 1 squared, is equal to 1 over cosine squared, which is your secant squared of theta. Now this is your third and final trig identity here. We'll highlight that one. So what we're going to be seeing here is some of these identities written in one form or another. So if you see sine squared plus cosine squared, it's equal to 1, or some variation of this. Same thing here. If you see 1 plus cotangent squared, it's going to be cosecant squared, again, or some variation. And then last, we have tangent squared plus 1 is equal to secant squared. So again, if you see something that says tangent squared plus 1, we know that to be secant squared. So we can simplify. So we might take something that's a little more complicated and then simplify it further. So let's take a look. So when it says identities enable us to write the same expression in different ways, it is often possible to write more complicated expressions, but as a simple way. To simplify algebraic expressions, we use factoring, common denominators, and special product formulas. We use the same techniques with your trig. So we're going to see these in all shapes and sizes. Yes, you can factor with trig. Yes, you can get a common denominator. And yes, you can use these special product formulas. So first, when you see something like this, when it comes to something that's in a little bit more expanded, the first tip that we want to do is put all terms into sine or cosine. That is, if you don't see an immediate identity that can be used, and it can again just comes up with patterns and just this is more or less like a puzzle, trying to get it into something a little bit more condensed. So if you notice that there's no identity to be used at the beginning, then perhaps if we get stuck, let's try to write everything in terms of sine and cosine. So in our case, there's no identity to be used. Yes, there's a cosine. Yes, there's a sine, but notice that we can't use your identity. So instead, let's write your tangent to write as sine theta over cosine theta times sine theta. Now, what would you do algebraically here? Right? Well, algebraically right here, we're going to be treating this as x times x, right? Sine times itself, meaning that we have x squared. So a lot of the times your next question might be, or your next step would be to ask yourself, what would you do algebraically? So if we have x squared, or sorry, x times x or sine times sine, we can combine those to make sine squared. Now, what would you do algebraically? Well, right now they don't have, right? You have a cosine and then you have some fraction with a cosine. And no, these aren't going to, they're not going to combine like, or cross out, I should say, right? That's not how that works. We can say, okay, well, if we're trying to simplify, we have y plus x squared over y. And if I'm trying to simplify, get something as small as possible, and I'm trying to add these two functions or add these two ideas together, we might want to consider getting a common denominator. So putting cosine over 1, we can tell that your common denominator here would be cosine. So in our case, we now should get cosine squared of theta plus sine squared of theta all over cosine of theta. And no, you cannot cross this out because then you're all the way back at the step before. Now, is there anything that you can now do? Well, we can use your trig function identity where we had sine squared plus cosine squared is equal to what, right? So here, now we can use your trig identity. We said sine squared plus cosine squared is equal to 1. So we can say that this is now 1 over cosine of theta. Now, do you know anything about 1 over cosine of theta? Well, cosine, or 1 over cosine, is really secant of theta. So that just means that this whole thing could be condensed into a secant of theta. Now, if you're having a hard time connecting this piece here to why we did the 1, right? We're replacing this expression that we have right here with its product, right? With its output. That output being 1, we're just replacing right here. So again, to kind of recap, if we get stuck, if we can't use an identity in the first place, we want to perhaps put everything in terms of sine and cosine. Then we want to do what we can algebraically. Combine your like terms or combine like you normally would, like get a common denominator. That's what we did right here. Common denominator. Let me move this over. Common denominator. We then were able to use a trig identity and then try to get it as small as possible. So let's have you pause the video and try it again with B. So cotangent or cosine and tangent, right? Cosine of x times sine of x over cosine of x. Now, what do you notice here? Well, algebraically, your cosine can cancel with one another through that multiplication. So therefore, we had just are given sine of x. So this whole thing can simplify into just sine of x. Let's try it again on our next one. So see if you can pause the video. So I'll pause it right here, see what you can come up with for C and D. So we have secant of x. So we have secant of x, which is 1 over cosine of x. I wrote that to the side. Over 1 over sine of x. Now, can we leave it like that? No, right? You have a fraction over another fraction. So we're going to keep change flip. And I'll write that here. Keep change flip. 1 over cosine of x times sine over 1. Combine them. We have sine of x over cosine of x, which can simplify to just tangent of x. So that just means this whole thing to start is reduced into just a tangent of x. Let's do it again with D. So again, no trig function can be used at this point yet, or trig identity. So instead, let's just convert everything. So you have cosine of theta over sine of theta. That is what your cotangent is. Then we have 1 over sine of theta minus sine of theta. And this is over 1. So again, let's try and work to get your denominator to simplify a little bit. So we need a common denominator here. So common denominator for us would just be a sine of theta. So now we have cosine of theta over sine of theta all over 1 minus sine squared of theta. So this sine times itself is just going to give us sine squared all over sine. And no, we don't want to cancel these out because then we're going to work backwards. Now at this point we can, if you wanted to, perform keep change flip, but I want you to try and think outside the box. Can we simplify your denominator just a little further? We do have a trig identity here. That is 1 minus sine squared. Of your trig identities, this one is most similar to sine squared plus cosine squared is equal to 1. So how did we go from here into here if this is an actual trig identity? Well, if we subtract your sine squared to the other side, we have cosine squared is equal to 1 minus sine squared, which is exactly what we have right here. So that means that 1 minus sine squared is equal to what? Well, it's equal to cosine squared. So I'm going to rewrite this whole thing where we have cosine theta over sine theta all over cosine squared of theta over sine of theta. And I'll notice that I didn't include that sine or that theta value, right? But we're just taking this portion of this trig function, right? This was the original, and you can still add and subtract to kind of manipulate your trig function. It doesn't always have to come in this form. In fact, it rarely comes in this form. It might be one form or another. So if we have 1 minus sine squared, it's equal to cosine. If we add 1 minus cosine squared, then it's equal to sine squared. So it can use one form or another. So now we can perform keep change flip. because you have a fraction over a fraction. And this could have been done after as well. I just am a fan of cleaning everything up first and then flipping. Now what's going to happen? Well, your sines are going to cancel. One of your cosine is going to cancel with the bottom one. So we have 1 over, and we have a cosine of theta left over, which means that this whole thing is really a secant of theta. So this whole thing can be written as secant theta. So this is kind of like a puzzle piece, and we can use all of your other trig identities in one form or another. So this one's variation we just said was cosine squared is equal to 1 minus sine squared. You could also have it flipped. Sine squared is equal to 1 minus cosine squared. And the other ones are the same as well. Just by adding or subtracting either the 1 or the cotangent, we can get other variations of your trig function or your trig identities. So let's say we subtracted the 1 to the other side. So that just means your cotangent squared is equal to cosecant squared minus 1. Or perhaps you don't want to subtract the 1. Instead, you maybe subtract your cotangent squared. Our other form of this trig identity is 1 equals cosecant squared minus your cotangent squared. And you'll notice that I'm just doing a very quick abbreviation. I'm not even putting my thetas or my x's, or my degrees, whatever symbol that you end up using, right? I'm just very quickly writing it. Lastly, we have some other trig function down here, or trig identity here. Notice that we could subtract the 1 and come up with tangent squared is equal to secant squared minus 1. Or instead of subtracting 1, maybe you subtract your tangent squared to get 1 is equal to secant squared minus tangent squared. So for all of your trig functions or trig identities, I don't know why I keep saying trig functions, you can actually come up with many different variations of the same identity. So we can use these as a shortcut value. So if you see cosecant squared minus 1, put it into cotangent. Or make it be a secant squared minus tangent squared. That is something right off the bat, right? Set it equal to 1. You just have to be able to practice enough to recognize that these are possibilities. So now let's move on to proving trig identities. So typically we want to work on just one side to start. At least for our class, the ones that I'm going to give you aren't as nearly as complicated. If they are super complex, then you can simultaneously work on both sides. But for me, you only really need to pick one side. Now, the side that you want to work on is going to be the one that is most complex, because it's easier to go from something that is super, super complex, looking into something a little bit easier and smaller versus going from something small and then trying to make it a lot bigger, a lot more complicated. So again, we want to start, if we kind of get stuck and don't know where to start, we want to put everything in terms of sine and cosine. So let's take a look at example 2A. Now, which side would you say is more complex? I would say the left side is a little bit more complicated because you're working with a fraction, and it's not always the easiest thing to make fractions. So let's go ahead and work on this particular side. If you wanted to, you certainly can work on the other side simultaneously. Ours are just not as complicated, so we don't really need to use that tactic. So let's take a look. We can say tangent squared. We can rewrite that as sine squared x over cosine squared x. Now again, if you wanted to use a trig identity as well, right? We just learned what tangent squared could be set as, which we said tangent squared could be secant squared minus 1. Maybe perhaps that's a better possibility, right? But it's not just going to cancel automatically with something like that down below. It has to be the exact same. So just keep in mind, sometimes there are different paths when we get started. So that is all over 1 plus 1 over cosine x. And again, we're just for me, working on one side. And like when you first get started, one tactic to do it is just to rewrite everything in terms of sine and cosine. All right, next, let's clean up your denominator. What would we like to do on the denominator? We might want to come up with a common denominator. In our case, let's put a cosine down below. So we have sine squared of x over cosine squared of x all over cosine of x plus 1 all over cosine of x. All right, now that everything is kind of fixed up, there's not much I can do to take this any further. So let's go ahead and keep change flip. See if things might cancel. So if you have sine squared, cosine squared times cosine over cosine of x plus 1. Notice that your cosines are going to cancel. One of your cosines with the other is going to cancel. So that's pretty nice for us. So now we have sine squared of x all over just one of your cosines of x times another cosine of x plus 1. Now this cosine of x plus 1 is working together as a team. So they are in the denominator. So they're working together. So now what can we do? Well, what we can do, I'm going to give myself a little bit more space. I'm going to move this back up here. And this is, again, just one sort of method here. So we have, let's see, sine squared of x over cosine of x plus 1. Now, keep in mind at this point in time, there are many different avenues that we can take. One such avenue is perhaps now using a trig identity, because there's a lot of cosines here, and what I really like is this cosine squared this cosine plus 1. Again, if you wanted to distribute your cosine in, you could have cosine squared of x plus 1, x plus cosine. So that is also another avenue that you can take, but you end up getting into the same thing where you now have a sine, a couple of cosines, and perhaps need to use an identity. So sometimes we might want to use your identity a little bit sooner than we might have think. So what do we know about sine squared and an identity? Well, your identity, right? Think about it. If we had sine squared plus cosine squared is equal to 1, all we are doing is that we now get to solve for sine squared, meaning that we have subtracted your cosine to the other side. So I'm going to have my trig function or trig identity now at the top be 1 minus cosine squared all over my cosine of x plus 1. Now we talked about using some factoring, some common denominators, some algebra skills, right? We still get to factor when it's in a when it's with your trig function. So at this point in time, we're perhaps going to be using some other factoring and algebra skills. So if I were to rewrite 1 minus cosine squared in terms of maybe something that we've seen before, have you seen something like this? Or maybe if I rewrote it as, let's say I factored out a negative, something like this, right? Well, this is the difference of squares. We know how to factor these. We just have a 1 and a 1, an x and an x, and we alternate your signs. But for us, however, we're not working with an x, we're working with a cosine. So we can put that all the way back in and just replace, and I didn't get a chance to show you where that had tracked, but we get to break it up now in terms of items that we have seen from before. So we have 1 plus cosine of x and 1 minus cosine of x all over cosine of x and cosine of x plus 1. What do you notice now? Well, we can clearly see that these will cancel because that's the only way you can cancel with a binomial. So we're left with 1 minus cosine of x over cosine of x. And no, those cosines are not going to cancel and be left with 1, right? You need parentheses, you need a binomial in order to cancel. So instead here, keep in mind, we're getting really, really close to secant of x minus 1. Right now, we're at 1 minus cosine of x over cosine. Can you see what they did? How to go from here to here? Well, they just broke it up to have now two separate fractions. 1 over cosine of x minus cosine of x over cosine of x, right? They now just share a common denominator. In which case, do we know anything about 1 over cosine? Well, this is just secant of x. And then you have cosine over cosine, so that just comes out to be 1. So to verify, you need to get all the way to the very, very end. And as long as those values match or those terms and expressions match, we've done it correctly. And if this is just going to take some time with some practice, some variations are harder than others. Like our next one, we might have, we haven't done this variation in a little bit, or the algebraic variation of it. So we can help you certainly get started with it. But the more that you practice, the easier it's going to get. So let's take a look here. We have cosine of u over 1 minus sine of u is equal to secant of u plus tangent of u. So again, choose a side that you want to work with. For us, perhaps this one is a little bit easier to work with because it is more complicated. But again, it's just a suggestion that we work just one-sided. So if we're talking about algebra, factoring, right, what we have seen in the past, believe it or not, is that we can multiply by something called your complex conjugate. Because right now we have 1 minus sine of u. And wouldn't it have been nice if it was 1 minus sine squared of u? Because then we could just say, oh, hey, you know, that is just the cosine of u. We were so close, but we were just off by a little bit. So instead, in order to get that product out, we can multiply by the complex conjugate. This is what we learned from chapter 1.2 at the very end, at the honest to God, our very last, one of our very last problems on that section, is that if we have x minus 1, right, what we can do is just alternate your signs. Multiply by an x plus 1. Therefore, when you FOIL it out, you'll end up with x squared minus 1. So if we did the same, if we have 1 minus sine of u, we can alternate and multiply by 1 plus sine of u. Therefore, we can get 1 minus sine squared of u. And again, this is just coming from FOILing. If we need to see the FOILing process, let me try that one more time to pull that down. This is just 1 times 1 minus plus sine of u minus sine of u minus sine squared of u, or sine times sine. Your middle terms cancel, and you're left with 1 minus sine squared. All of this, now that we have your trig identity, is cosine squared of u. So this whole thing on that one side could be equal to cosine of u if we multiply the denominator by 1 plus sine. And what you do to the denominator, you do to the numerator. So up top, we have 1 plus sine of u times cosine of u all over cosine squared of u. What's going to happen? Well, this is going to cancel with the 2. So now we have 1 plus sine of u over cosine of u. How do we get to secant plus tangent? Well, same idea as last time. We can break it up to show it has a common denominator. We can only do this if we have a monomial down below. 1 over cosine is secant. Sine over cosine is tangent. So sometimes you have to think outside the box in order to get started. This just comes from practice. So if you're not getting it to start, it just needs to, you just, honest to God, need a little bit of practice. And again, these are verified. They are the exact same on either side. Please check out our next video just to kind of reiterate the skill of just trying to either verify or simplify.